Today we are going to see the graphical method from the unit called linear programming problem, shortly known as LPP. So this is the form of an LPP. It consists of three components: objective function, constraints, and non-negativity restrictions. So this is a sample problem. We are going to solve the problem right now. So I am going to take the second problem because it is we have to formulate the problem first, then let us solve the problem by using graphical method. So a company produces two types of tires. Okay, every tire A requires twice as much labor time as second tire B. So if the company produces only tire B, then it can produce a total of 500 tires a day. The market limits daily sales of tire A and tire B to 150 and 250 respectively. So the profits on tire A and B are rupees 8 and 5 respectively. So formulate an LPP and solve the LPP by using graphical method. Now we have to formulate the LPP first, which means we will have to find the objective function. In order to satisfy the objective function, we will have to follow certain rules and regulations. In other words, in technical terms, it is called constraints. So objective function, constraints, and then non-negativity conditions. The three components put together called a linear programming problem. Okay, so let the number of units produced by the tire A is x1, tire B is x2, because that is what we are going to find at the end of the problem. So how many number of tire A should be produced and how many number of tire B should be produced. So profit of the tire is 8, therefore number of tires produced is x1, therefore 8 into x1. So that is what over here. Similarly, profit of tire B equal to 5 into x2. Therefore, total number of profit by the company is 8x1 plus, because total 8x1 plus 5x2. Now the LPP is objective function, maximize z equal to, z is the objective function. Why we are putting maximize? Because we are going to maximize the profit. The z is profit, therefore we are going to maximize it. If the z is expenses, suppose the number of tires produced in the type A is 8 rupees cost, then we will have to minimize it. If cost is given, if expenses is given, then we will have to minimize the objective function z. Whereas here we are given profit, therefore we are maximizing it. So maximize z equal to 8x1 plus 5x2. Constraints, when it comes to constraints, the condition is every tire A requires twice as much as time of the second tire. Therefore, the time taken for second tire is twice the tire manufactured for the first tire, which means 2 minutes. Suppose we are taking in minutes, 2 minutes will be taken for making one tire and 1 minute is taken for making one tire in B. So 2 into x1. So total number of tires to be produced is x1 in A. So 2 into x1 plus x2, which is less than or equal to 500. 500 is given over there. Next, total number of tires limited to the sales, daily sales is x1 less than or equal to 150 and x2 less than or equal to 250, tire B. Non-negativity conditions. So non-negativity condition means the company will always produce the tire in a positive number. Otherwise, the company will be closed, means will get 0. Therefore, x1, x2 number of tires produced in type A and type B must be greater than or equal to 0. So this is the LPP. Now we will have to find the points. Now we are coming to solve the problem by using graphical method. Now I am going to find the pair of points for each and every constraints. First constraint is 2x1 plus x2 is equal to 500. Why we are taking equal to? Because less than means you will get more number of points, infinite number of points. Therefore, we are going to convert it into equal to sign. Therefore, simple calculation I will tell you, put x1 equal to 0. Therefore, x2 equal to 500. Similarly, put x2 equal to 0. Therefore, 2x1 equal to 500, which means x1 equal to 500 by 2, 250. Therefore, we will get two pair of points. 0, 500 is 1 point. The other pair of point is 250, 0. So for every equation we will get a pair of points. For the second equation, x1 less than or equal to 150, but we will have to convert into equality sign. So x1 equal to 150. So x1 equal to 150 means irrespective of x2, whatever may be the value of x2, the x1 value must be 150, which means 150 for any value of x2. So 150, n, which means 150, 0, 150, 100, 150, 200, 150, 300 and so on. So similarly, x2 less than or equal to 250 means for any values of x1, the x2 value is 250. Therefore, n, 250, 0, 250, 100, 250, 200, 250 and so on. So these three pair of points should be represented in a graph. So this is x-axis, this is y-axis. So we call it as x1, this is x2. So first pair of pointers 0, 500 and 250, 0. So 0, 500 this point and 250, 0 is this point. So joining these two lines. So this is the first constraint. Second constraint is 150, n. So 150, n means x1. In x1 it is 150. In x1 it is 150. The x2 irrespective of x2 means x2 may be anything 100, 200, 300, whatever. Therefore it is the vertical straight line. Similarly, x2 must be 250 irrespective of any values of x1. Therefore, it is a horizontal line. In x2 equal to 250. Therefore, we have got all the three lines in the graph. But we will have to find the solution space. How to find the solution space? Where we are going to get the actual values. Actual inequality. All the inequalities are in less than. So, less than or equal to signs mean less than or equal to sign implies that you will have to take the space below the line. Less than means below the line, greater than means above the line. So your answer lies in the below the line, actually below the line. For example, this the answer is lies between this to this and this. So this area only you are getting the answer, which means because above the line we will not get the answer above the line. So similarly for this line also, if it is a vertical line, then less than means left hand side of the vertical lines, greater than means right hand side of the vertical line. So I am coming in the opposite, the other way around. What are all the spaces which are not coming into the solution? See, this is below the line. Answer lies between the below the line, which means here it will not come. Answer will not come over here. Answer will not come here. Answer will not come here, and the answer will also not come over this area also. So there are only three possibilities of area where you will find solution space. As far as this line is concerned, below the line again. So above the line, this area will not come. So balance here, you will get only two areas. So here also above the line, this will go into the above line, below line only, because it is also less than or equal sign. Therefore, the required area is starting from here, go to there, and here, and coming over here, and this. So this is called it as O, A, B, C, D. So O, A, B, C, D. These 5 points are called solution space, feasible region, or solution space we can call it. So these points you can take it from graph. So those points are referred here. You can take it, actually the problem must be in graph only. Therefore you have to take the actual points. This point is directly x1, this is x2. So for example, sorry, x1 is 125 and x2 is, this is 125 and x2 is 250. Similarly, this point, x1 is 150 and x2 is 200. So you will directly get it from actual graph. Therefore, we will get all the 5 points. We have to substitute all the 5 points in the objective function. What is the objective function? Maximize z equal to 8x1 plus 5x2. So you have to substitute both x1 and x2 values over there. Therefore, you can have these 5 values, out of which is going to be the answer. That is what we are going to find. So actually speaking, all the values are the answers. So starting from O, A, B, C, D. So in this region, what are all the values available are called solutions. But we want maximized solution, because our objective is to maximize the protection, so that we will get the maximum profit. So 2250 is our maximum value for out of 5 points. Therefore, 125 units of tire A and 250 units of tire B to be produced, so that we will get the maximum profit of 2250 for this problem. This is called optimum solution. Thank you guys. We'll see the next video on simplex method. Thank you.